welcome to Lesson 7 in our chemistry unit. This is the second part of Chapter 6, and today we're going to be talking about elements and compounds. So remember that we were talking about pure substances and mixtures in the last lesson, and today we're going to really talk about just the pure substances and how they break down even farther. Okay, so pure substances are either elements or they're compounds, and their properties are always the same. People used to believe that gold could be made out of other metals, such as iron and copper. No matter what they mixed together, they never managed to make gold. They did, however, discover other elements besides gold and discovered that elements could be combined to form compounds. There are 92 elements that occur in nature. Most are the ones that you're familiar with: oxygen, carbon, iron, gold, silver, and copper. There are about 113 elements in the periodic table, and each has a name and a symbol. The symbol is an abbreviation of the name, and it is used in chemical formulas and equations. The symbols don't always seem to match the name. Example, Au is gold. This is because many of the names come from their Latin roots. Elements can be either metals or nonmetals. Elements that are metals have the following properties: luster, which is how shiny it is; a silver gray color except copper and gold. They're malleable, which means they can be hammered into different shapes. They're ductile, which means they can pulled into wires. They're solid at room temperature except mercury, which is a liquid. And they have conductivity, which means they can conduct heat and electricity. They also form a number of compounds because they are chemically reactive, and the only two that aren't chemically reactive are gold and platinum. Elements that are nonmetals have no luster, they're brittle, they do not conduct heat or electricity except for graphite, which is a form of carbon, and are either solid at room temperature or a gas. Only the element bromine is a liquid at room temperature. They also can form many compounds because they are chemically reactive. With the exception of the noble gases helium, neon, argon, krypton, xenon, and radon, elements can be further subdivided into atoms and molecules. Molecules are two or more atoms held together by chemical bonds. They're too small to be seen without a very powerful microscope. So we all know that atoms are the smallest unit of an element and are composed of protons, neutrons, and electrons. Each element has a unique atomic number, which corresponds to the number of protons in its atoms. Atoms are not broken down during normal physical or chemical changes. They are the building blocks of all matter, which we have known from the beginning of this unit, that matter is made up of everything, and atoms are the building blocks of that matter. Now, Mendeleev published the periodic table in 1869 using only 64 of the known elements at the time. It was successful because it allowed for empty spaces for undiscovered elements. Different elements have different properties because they have different particles, and we talked about this in the last one. Compounds have different properties than the elements that make that compound up. So individual elements lose their unique properties when combined with other elements, and we will talk more about this as we go through this section. Remember that there are millions of pure substances. People have been investigating pure substances for thousands of years. 10,000 years ago, people learned how to extract copper by heating the ore and melting out the copper. Alchemists in medieval times tried to break down the metals to make gold. They never succeeded, but what they did discover is that some pure substances could not be broken down into other pure substances. This is why we classify pure substances into elements and compounds. So here's our extended graph that we were showing in the last one. The last time we looked at this, we didn't have the elements or compounds on here now. So now we're just extending down. So we have our matter, which is made up of atoms and molecules and makes up everything in the universe. Matter can be broken down into our mixtures and our pure substances, remembering our pure substances containing only one type of particle, our mixture containing two or more types of particles, and then our elements, okay, are one type of pure substance, and our compounds are a combination or a blending of two of those elements. And we'll be talking more about this in a minute. So elements. Elements are pure substances that cannot be broken down into any other pure substance. That is the main definition that we want you to know here, okay? So elements, pure substances that cannot be broken down any farther. Compounds, on the other hand, are pure substances that are made up of two or more different elements. They can be broken down sometimes, but often it's quite difficult, okay? So let's go back to elements. Elements is composed of a single kind of atom, and the atom, as we know, is the smallest particle of an element that still has all of the properties of that element. So what we mean by that is if we're looking at gold, gold is an element. If you slice and slice and slice that gold until only the teeniest, tiniest particle is left, that's an atom, and the properties that make gold gold can still be found within that atom, okay? So Remembering too that atoms in an element all have the same number of protons. Protons are subatomic particles, particles of an atom. Elements, therefore, are the building blocks of matter because they are made up of atoms, which are the building blocks of matter. Okay, so if we go over to compounds, compound composed of two or more elements in a specific ratio. For example, water is made up of two elements, hydrogen and oxygen, and we know that the ratio of that is 2 to 1, right? So 2 hydrogen atoms to 1 oxygen atom. You combine those together and you get the compound that is called water. So now when we talk about that, we talk about the fact that the properties that make hydrogen, hydrogen, and the properties that make oxygen, oxygen, when they combine together, those properties disappear and you now have the properties of the compound of water, which are different than both hydrogen and oxygen. So it becomes a unique combination of the two elements. So, and as I mentioned earlier, chemists can't easily separate those components of a compound, and if they can, they have to resort to some type of chemical reaction within there to try and break them apart. Just as mixtures, compounds can be solids, liquids, and gases. Different elements have different properties because they have different particles, and that should be reviewed. In the same way, different compounds have different properties because they have different combinations of elements. So, for example, the properties that make up water are different than the properties that make up salt because you're looking at different properties that make up those compounds. And we also mentioned that the compounds may have completely different properties from the elements that make them up. And table salt, again, is an example. Sodium and chlorine are both very poisonous on their own, but when they are chemically bonded together to create a compound, completely different, and it's no longer poisonous and is actually good for your body. So we will going to do some work with some elements and some atoms in our next class, and we will talk more about this later.